All right, we're going to do an example of Kepler's third law. So Kepler's third law, just a quick refresher, is period squared divided by the semi-major axis cubed is going to be the same for all objects orbiting a common object. The example we're going to do today is two moons of Jupiter. So they both orbit Jupiter, so they have a common orbiting object. And so their ratio of period squared divided by the semi-major axis cubed is going to be the same. Okay. Semi-major axis cubed, sometimes you'll see this just written as an R because a lot of our orbits are fairly circular, so we just use an average orbital distance there. So sometimes you'll see that as an R for whatever reason. Okay. So here we go. I have Europa. I know Europa's period is 85 hours, so every 85 hours Europa circles Jupiter, and it's 6.71 times 10 to the 8th meters center to center between the two. On average. Io's closer. So Io's at 4.22 times 10 to the 8th meters, so it's a little bit closer to Jupiter. So we can conclude that, if it's closer, that means it's got to be moving faster to stay in orbit. And so we should see a smaller period. But let's figure out what it is. So because they both orbit Jupiter, their period squared over semi-major axis cubed is going to be the same thing. Okay? It's a constant. So what we can do for this is I can set the two equal. So I can say 85 squared divided by 6.71 times 10 to the 8th cubed equals the new period, the period of Io here, squared divided by its orbital. So 4.22 times 10 to the 8th, 10 to the 8th cubed. We can cross some stuff out here, and this is kind of the nice thing about this equation is you just need common units. So if I put in hours, I get out hours. I got to put in meters, I can get out meters. In this case, I might just say, well, I'm going to put it in terms of 10 to the 8th, and so I can just put in 6.71 and 4.22. When I solve this, I find out that the period of Io is 42 hours. And so you'll find with these inner moons of Jupiter, they're going to have this kind of ratio that pops up for their periods. Okay. All right, there's Kepler's third law.